Thank you for coming here and taking a hybrid approach to machine learning. What I want to do today is to argue that actually the machine learning, which is the synonym of AI these days, has a bit of pitfalls. Those pitfalls don't work too well with the challenges that chatbots have in the enterprise world. And then, if I have time, I hope so, I will give you some ideas of what we're doing about this. We know about the challenges, but we also, to put the pressure up, we have Gartner predicting, and Gartner's of course always right, that in 2020, chatbots, or virtual assistants as we call them, they will do or appear in 25% of the customer service and the support organizations. So that's of course quite a big challenge with all the talks here about not having, or chatbots not being ready for the enterprise world. But there is hope, because enterprises do live in the enterprise and the corporate world already. That is, of course, my sneaky in marketing page here, but it's also about telling you guys that chatbots live in very big companies and they work in the financial industry. Not sure who's been here at 11:15, so they do all that. Still, there are challenges with chatbots, and let me review those quickly with you. There is the... Is that helping me? Well, anyway, you see this, there's the integration bit. Of course, if you want to be more than just a glorified FAQ system, you want to reach out to other bases of knowledge, and you want to talk to the back end to make things happen in the real world. You have the compliance issue. Each corporate, you go to, has its own legal procedures, has its own security procedures, all things like that. And you have the task of customization. If your chatbot was built for one nice use case, still bringing that to the next company will face you with some challenges. And the customization thing, the domain knowledge, as it's also often called, is much more than just a list of synonyms or new terms for something else. I claim that natural language understanding, and hence good chatbots and virtual assistants, are only smart if they're context dependent. Everybody will nod to that. But this context is about really the industry, it's about the company you're doing it for, it's about the scope of the project you're doing it for, it's about the target group, it is about the location and the media through which you show your virtual assistant, and if you want to go conversational, it's the state of each single conversation that changes how to interpret a user input. So that's a very, very big challenge that we have here. And if that is not enough, we have the ROI, we have the timeline, we have the budget, and we have the problem of predictability. All of that is, of course, important if you want to do something, let me call it serious, in the corporate world. Now, what I'm saying is that these are the challenges, and here are the pitfalls with self-learning, or let's say with deep neural networks. And there's one is the garbage in, garbage out problem. Of course, we heard all this. I heard you guys applaud. You need good data. You need a lot of data. Data needs to be normalized. And the quality of the data in a company is usually of the quality of the data in the company. You don't have bad data, or you don't have data at all. That's what we very often have. In neural network, especially the latest hot thing, the machine learning with deep neural networks, they work with hidden layers, and those hidden layers are hidden. Which means you have a hard time to find out what did they do, why did they do this, and if you could unveil the hidden layers, what you see is a number representing the connection between two neurons. So predictability and understanding why is a very tough thing. And one thing that is less obvious maybe is that machine learning is not flexible. You start from given data, you start from a given architecture, you start from a given learning mechanism, you start from, I think, even some more parameters, and then you let it learn, and then you hope that it works. And you test it, and if it doesn't, you're going back. And it could be your data, it could be your learning algorithm, it could be your architecture. I have a very, there's one thing. And if you have special cases, every company has special cases, a neural network can learn special cases if they are very frequent, or frequent enough in the data, which is not going well with the idea of a special case, of course. So I found a very nice visualization that ties into the talk that you just heard. Here we have a neural network that identifies a panda in an image. Okay, now we add a bit of noise to that image. The outcome is there on the right, and now the neural network is 99% sure that this is a gibbon. And that is not an exotic case. You can create that quite easily. And really, we have no idea what's going wrong. We have no idea why this should be a given here on the right-hand side. So that's my point is that neural networks are quite different from human brains. They're very bad approximations how the human brain works. Still, there is a remedy. Something is missing, but we can help. And for that, I have two rhetorical questions for you. The one is, if agents, really human agents in your call center, if they were quicker readers, would your approach actually be to have them read a month of chat transcripts or a terabyte of chat transcripts to find out how is the policy for resetting passwords? Or, if they were multitaskers, would you give them 5 screens and watch other agents in action and try to work out what questions to ask for to open an account? The answer is, of course, no. The answer is no. It was a rhetorical question. So, however, the response or the answer might not be totally obvious. There is declarative knowledge. There is explicit knowledge. There's standard operation procedures in every company. And sorry for a stark term, and neural networks can do great stuff. But if you have this knowledge explicitly, it's nonsense to ask a system to learn it. You teach it. You tell the system what to do. That's where you start from. What shall the system do? And the nice thing is neural networks can really help you then to find out when is a good moment to do what you told the system to do. So, in a bit more detail, this is how it works. We start with an unsupervised pre-learning, generic language model that we create. But now here comes the human brain. Human beings say, this is what the system shall do. These system actions need not be static. Look up into knowledge bases, talk to web services, get in dynamic data. All that thing is happening, but still within the real time, within the dynamic nature of your system responses, you still have predictability about what the system is doing. You tie those actions together, you bring in special cases, you create special content or context if you need multi-step thingies. And human beings also then create a nice set of examples when to bring up these system actions. And now here comes the machine learning aspect. In a way, I think it's fair to say that this approach creates fixed points for the neural network. Local constancies, and those help the neural network to avoid these funny little things that a given, a panda plus noise becomes a given. We call that the hybrid approach because it's human beings telling the system what to do. It's the system learning when is a good moment to do this based on human-created examples. You can do this for the creation of the content, and you can also do this then for the improvement of content. Watch agents give answers. You can then also have present lists, and then customers choose the best matching action, the most appropriate response from the system. You can use that. And if you're daring, you can throw away the creation part and start from scratch and do it all by watching agents and users. After this talk, you will know that I find that a bit nonsensical. If you know the top 200 questions that give you pain in your call center, why not put them in? But of course, it is a mode that you could apply, just learn from that. The fines and benefits for this approach is that we find that our neural networks can live with quite small receptive fields, which actually means that the appearance of a word in the user input is the most important thing. We don't have to worry too much with syntax and grammar and things like that. We just heard from Jordi that book a ship and ship a book is vastly different. However, really, how many bookstores rent ships? And that is exactly my point. Discussion of the international shipping policy is not relevant for a bookstore. And therefore, this whole mess of understanding a lot and then not having an answer for it is removed by coming from the point that I tell the system what it shall do. Our neural networks are quite robust against parameter variations, which is lovely. We optimize the stuff, and what we've done, we can apply to the next project. We're not starting again, or at least we don't have to think about new architecture, new learning, blah, blah, blah. And we only need two handful of examples to get the network learning. Great results. I think we are in the high 70s to find the best matching response to user input in our test there. So accuracy is 70-something%. If we are allowed to present a list of potentially appropriate user system responses, then we are beyond the 90% mark. The best matching response is there. Is that 80 or 90? 9 minutes, 10 minutes? The beep? I thought that was a warning. Okay, fine. Anyway, let me read this to have a nice summary here. Hybrid approach of human creation of content and self-learning minimizes the risk in the creation. It allows the system to continually improve, and it gives you still control about the virtual assistants or the chatbots responses. That's me. I'm done. And if you didn't like it, find me there or find us on booth 13 for more.